The function f is given by f of x equals 2 sine of 4x plus cosine of 2x. Using the period of f, which of the following is the number of complete cycles of the graph of f in the xy plane on the interval x is from 0 to 1000 inclusive. So first we need to find the period of this graph, and we can use the period to find out how many times the graph completes a cycle from 0 to 1000, since the period is the amount of time it takes to complete one cycle. So we can graph this function in our graphing calculator, or I did it in Desmos in this case, but you can do it on your graphing calculator as well. So now we have this graph of this sinusoidal function. We just need to find the period, and the period is the amount of x units it takes for the graph to complete one cycle. So let's choose a point on this graph. I chose this point up here, and we need to find out how many x units it takes to go from this point on the graph back to the same point. So we see the graph goes down, and then it makes this small local maximum, and then it goes down again until it reaches this another local maximum at the same place as where we started. So that means the sinusoid between these 2 points is one complete cycle, and this just keeps on repeating and repeating. You could have chosen any other point to see when the graph comes back to that point, but I just chose the top of the curve here because that's easier to see. So the coordinates of this point are labeled here, so we need to find the difference in the x values, and that will give us how many x units it takes for the graph to complete one cycle. So the graph went from 0.35206 to an x value of 3.49365. So we can just calculate the difference between those, 3.49365 minus 0.35206, and this will give us the period. So we can put that into our calculator. So 3.49365 minus 0.35206, that equals 3.14159. So it seems the period was pi. Okay, so this is the difference in the x values here, and that's the period for our graph. So now we know how many x units the graph takes to complete one cycle. And if we're given 1000 x units in this interval, then we just need to divide the total number of x units we're given by the amount of time it takes to complete one cycle. And this will give us, so this is x units, and this is the number of x units per cycle. So when we divide this by this fraction, which is the same as multiplying by the reciprocal, so that means when we do x units times the reciprocal of this, so cycles over x units, we see that the x units cancel out and we're just left with cycles. So this will give us the total number of cycles the graph completes in 1000 x units. So 1000, if we put that into our calculator, 1000 divided by 3.14159 gives us 318 cycles. And the closest in 318 point some small fraction of a different cycle, that's probably because we're rounding. And so that means the graph completes about 318 cycles in 1000 x units.